Alright, welcome to part 5 lecture video of 1.2 atomic structure. In this video, finally we will talk about writing the electron configuration using subshell notations of an atom of any first 38 elements in the periodic table. Now, there are some exceptions, and those exceptions will be covered in the next video, but we'll talk about the main, rules regarding how to use subshell notation. Slide that I will be looking at first is this one, slide 17. Okay. So, in this slide, what it's showing is the subshell notation needs to have certain parts, and they need to be written in a certain way. The convention that everyone in the world agreed to. So electron configuration of hydrogen. Now, how many electrons are in hydrogen? Hopefully you're saying, yeah, just one. Good. Where does that electron live? It's gonna be in the main shell number 1. Therefore, you see, this one, you see large 1 in front of S. How many subshell does it have? Well, shell number 1 only has S shell, therefore it shows S. Where does the electron live? And how many electrons are there in the S shell? Now, S shell can only have up to 2 electrons, but hydrogen only has 1. Therefore, do you see the superscript number 1, superscript number 1 above S? Now, superscripted number means, well, that shows the number of electron. So copy the diagram there, and if you need to add any note, do that so. Okay, on the next slide, it shows a bit more rules there. So subshell notation is all about sectioning main shell, or separating electrons into different subshells, or the blocks in that main electron shell. Now there's an example there. Sodium, there are 11 electrons, and how would you write that normally? Well, if you start with that, it kind of makes more sense, and then we'll talk about how to write that with subshell notation. So sodium, if it's an element, there are 11 electrons. Now, you have been separating them using comma. And if you can remember how you have been doing that, you would have done in a conventional way. You would have done 2 in the first shell, 8 in the next shell, and left over 1 will just sit like that. That is fine. That worked okay. But I want you to start using subshell notations. If you're using subshell notations, you need to think about where do these electrons go in terms of subshell. First subshell, it's just like what you saw in a hydrogen. It's going to be in the first main shell, and S subshell is the only thing that exists, and there are 2 electrons in there. So 1s2 is firstly written. And you have to go to second main shell. Now, second main shell, if you remember, there are S and P shell, but they both belong to second main shell. Now, another thing, please don't add commas in between, because you don't need it. That's the convention we are using. 2s subshell can have up to 2 electrons as well, and there are 8 of them. So what's the leftover? 6. 8 take 2 should be 6. And how many electrons can fit into next subshell in the second main shell? 2p. Now, p subshells, maximum number of electron, if you refer to the last video, it's 6. So that makes up 8 electrons, doesn't it? And 2 is from just 2 main shells. What's the leftover? There's this one here. Where does that go? It needs to be in the next main shell, because main shell number 2 doesn't have any more subshell. So that goes into the third shell, and subshell that gets filled is S, because the energy level is lower in S. next P, D, and F at the end. So S gets filled first. How many electron is present in this subshell? Only one. So you just write 1, but a superscript number, superscripted number. So if you look at 1s2, there are 2 electrons there, and the next 8 electrons in the second main shell, and third main shell, 1. It's just about sectioning 281 into different parts in that main shell. That's all to that. So 281, and then 1s2, 2s2, 2p6, and 3s1. Now, there is a nice mnemonic to how you can fill up subshells like this. What you're seeing on here at the moment, that tells you how to fill up each subshell first. Okay, I'm going to talk about it in a minute. So if you want to remember which way you should go first, well, you draw that as well. 1s is the first subshell. You just write the numbers down. Just do S first. Next, P, but the 1s, the first main shell doesn't have any P, so you start there. So P, 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 there. Next is going to be D, and it only starts appearing in the third one. Oops, that's 4D. And you will have F. So for F, 5, F. And that's where you would stop, because you don't probably need any more than that. You then start using these subshells diagonally. So firstly, you have to fill 1s. Next is going to be 2s. After that, you move on to here, 2p and 3s. So 1s is always first, 2s next, 2p next, 3p comes after that. Then, oops, 2p, 3s, sorry, 3p, and then 4s. Now, interesting thing, 3D comes after 4s, which is okay. Just follow what it says here. So 3D, and then, oops, no need that, 4p gets filled after that. Keep following this. Make sure you have 3D after 4s and before 4p. This will be really useful later on. Now, before you finish watching, when it comes up, there you go. Can you try using electron configurations? Using subshell notations, I want you to write the electron configurations for these 8 elements. So, lithium, boron, neon, calcium, titanium, manganese, iron, and zinc. I'll let you try doing that, and we will look at the answers in class. All right, that's the end of part 5. Thank you.